Hello friends, myself R.D. Mahajan, Assistant Professor, MIT Aurangabad, presenting my next video on the topic Lagrange's method of undetermined multipliers from uh, third unit application of partial differentiation of engineering mathematics 1. Let us see the statement of that Lagrange's method or the explanation of that method. Let u is a function of three variables x, y, z, be a function of variables x, y, z. These variables are connected by a relation phi of x, y, z is equals to 0. We call this as equation 1. Then for u is equals to f of x, y, z, to have stationary values or extreme values, it is necessary that dou f by dou x equals to 0, dou f by dou y equals to 0, and dou f by dou z equals to 0. It is exactly similar to the condition whatever I have discussed for maxima minima for the function of two independent variable. Here it is function of three independent variable. Therefore, this condition is called as a necessary condition for to have that stationary values. It implies if you find the total derivative of this f with respect to x, y, z, we get dou f by dou x into dx, dou f by dou y into dy, dou f by dou z into dz equals to 0. We call this equation 2. This is the total derivative of that function f. Similarly, taking total derivative of phi, we get dou phi by dou x into dx, dou phi by dou y into dy, dou phi by dou z into dz equals to 0. We call this equation 3. Then multiplying this equation 3 by lambda and then adding it to equation 2, we get, means what steps we have to perform? We have to multiply this equation 3 by lambda, and what was that? We have to add with 2, and if you perform that calculation, we get here first term is added with first term, second term with second term, third term with third term. When we add, we can take dx common. Therefore, we have dou phi by dou x, dou f by dou x plus lambda times dou phi by dou x. Then dou f by dou y plus lambda times dou phi by dou y into dy. Then when we add third, it is dou f by dou z plus lambda into dou phi by dou z into dz equals to 0. And then comparing two sides, we get here it is 0 dx, 0 dy plus 0 dz. Comparing the coefficient of dx, we get dou f by dou x plus lambda dou phi by dou x equals to 0. Dou phi by dou y plus lambda into dou phi by dou y equals to 0. And the third, dou f by dou z plus lambda dou phi by dou z equals to 0. We call this as equation 4, 5th and 6th. And then by solving equation 1, by solving equations 1, 4, 5 and 6, 4, 5 and 6, we can determine, we can find or determine the values of x, y, z, values of x, y, z and lambda for which that function f of x, y, z has stationary values. Has stationary values. Therefore, how we can obtain that stationary values for function of three independent variable, that is using this Lagrange's method of undetermined multiplier, or this technique is called as Lagrange's method of undetermined multiplier. I will explain it by solving two simple examples. Divide 24 into 3 parts. Divide 24 into 3 parts. So that the continued product of first square of the second and cube of the third may be maximum. This is the statement of that problem. Therefore, using this statement, we try to find out that values of three variables x, y, z. What is given here? We have to divide 24 into 3 parts. Suppose that parts are x, y, and z. Suppose, and therefore sum of all these 3 parts is 24. Therefore, x plus y plus z is equals to 24. Okay. Transferring this to other side, we get a function of x, y, z as x plus y plus z minus 24. And if when we transfer it to left hand side, it becomes equals to 0. We call this as equation 1. Okay. And another information is that such that the continued product that we call as function of x, y, z, for which we require to obtain the maximum value. What is the given information? It is continued product of first part is x, square of the second means y square, and cube of the third z cube. Therefore, we consider that function as x into y square into z cube. A continued product must be a maximum one. Therefore, we call this as second. Then, differentiating this with respect to x, y, z. First, we find out derivative of f with respect to x, keeping y and z constant. Therefore, its derivative is y square z cube, constant term we can take outside, and into derivative of x with respect to x is 1. Therefore, we get this one. Then differentiating with respect to y, this time x and z are constant. Therefore, x z cube constant. Derivative of y square is 2y. Okay, and then with respect to z, this time x and y constant term. and derivative of z cube is 3z square. Okay. Then we differentiate phi with respect to x, y, z. Therefore, dou phi by dou x is, what is dou phi by dou x? Its derivative with respect to x is 1. Other terms are constant term. Therefore, derivative is 0. Dou phi by dou y, derivative of y with respect to y is 1. Again, other are constant term. Derivative is 0. And dou phi by dou z, differentiating it with respect to z, we get 1. Okay. And then using that equations by Lagrange's method of undetermined multiplier, we have three equations. The first equation is dou f by dou x plus lambda dou phi by dou x equals to 0. It gives you substituting the values of dou f by dou x and dou phi by dou x. Dou f by dou x is y square z cube plus lambda into dou phi by dou x, it is 1, and that is equals to 0. We call this as equation number 3. Then second, dou f by dou y plus lambda dou phi by dou y implies, it gives you substituting the values. It is 2xy z cube plus lambda into dou phi by dou y, again 1, equals to 0. Equation 4th. And last, dou f by dou z lambda dou phi by dou z equals to 0. It gives you substituting the values of these two. Dou f by dou z is 3xy square z square plus lambda into dou phi by dou z 1 equals to 0. Fifth. Therefore, we have equation 3, equation 4 and equation 5. Then, using equation 3 and 4, we get from equations 3 and 4, we get from 3 we get lambda is equals to, if you transfer to other side, we get minus y square z cube, and from 4th we have lambda is equals to minus 2x y z cube. Okay. Same value, same lambda on left hand side. Therefore, equating right hand side, as we have same values on left hand side, it implies Yes, we have minus y square z cube as minus 2x y z cube. Z cube get cancelled, y, 1y get cancelled, minus minus it become plus, we get, here it remains y is equals to 2x we get y equals to 2x. Okay, by solving this two, then from equation 4th and 5th, for equation 4 and 5th we get, therefore from 4th once again we have lambda is equals to minus 2x y z cube, and from 5th we have lambda is equals to minus 3x y square z square. Again same term on the left hand side, lambda lambda, therefore equating right hand side term, it implies minus 2x y z cube is equals to minus 3x y square z square. Okay, minus minus get cancelled, x get cancelled, 1 y get cancelled, therefore here it remains minus, z square cancelled with z square, therefore z remains, minus minus it become plus, therefore we get z is equals to, here it is 2z minus 3y. Okay, and therefore we get z is equals to, minus minus it become plus. If we solve it for z, we get z is equals to 3 by 2 times y. Okay, using it in first equation, yes, that is x plus y plus z, x plus y plus z, that sum is 24. Okay, substituting or converting all in terms of x, therefore I will keep x as it is, y in terms of x is 2x, and z is equals to 3 by 2 times y, therefore we can calculate the value of z in terms of x, it is 3 by 2 times y, but what is the value of y? Y is 2x. So to get cancelled we get z is equals to 3x, therefore z is equals to 3x, and that is equals to 24. If we take the sum of this, 5 plus 1, that is 6x is equals to 24, we get x is equals to 24 by 6, and therefore six fours are 24. Okay, then put the value of x in y, we get y is equals to, therefore y is equals to 2 into x, x is 4, therefore we get the value of y as 8, and z is equals to 3x, 3 into x, x is 4, therefore it is 12. Okay, therefore these are the values of that variable x, y, z, so that function is maximum. Therefore the sum of all this, that is 4 plus 8 plus 12, we get as 24. First equation is true. And the second, okay, this is the required. Therefore, whatever this we obtain, it is by using Lagrange's method of undetermined multiplier. This method is useful to determine maxima or minima or the stationary values for function of three independent variable. Example, a rectangular box open at the top is to have volume of 256 cubic feet. Then the question is, determine the dimensions of the box requiring least material and use Lagrange's method of undetermined multipliers. Means using Lagrange's method of undetermined multipliers, we require to find the dimensions of the rectangular box which is requiring a least material to perform or to obtain this rectangular box. Therefore, we consider some one rectangular box where x is the length of that rectangular box, y is the breadth, and z is the height. Therefore, x, y, z, these are the length, breadth, and height of that rectangular box. Then we know that volume is length into breadth into height, and therefore volume becomes x into y into z, and it is given as 256. If we transfer this to left hand side, we get x, y, z minus 256 equals to 0, and we consider this as function of x, y, z, phi of x, y, z as x, y, z minus 256 as equation number 1. And then to obtain that material, we require to find the surface area. This rectangular box is having 6 sides, bottom, upper, this, and the back side. Out of the 6 sides, the upper top is the open, and therefore we try to find that material required by finding the surface area. Surface area is equals to this area as x into y, then this area as y into z, and the same in front of it, therefore it is 2 times yz, and this area this area, this length is x and this height is z, therefore that area is xz, and same side we have here, therefore it is 2 times xz. Therefore out of total 6 sides, upper side is open, therefore we are not multiplied here by 2, therefore that surface area is xy plus 2yz plus 2xz, and we call this as f. Therefore f is equals to, we have xy plus 2yz plus 2xz as equation number 2, and then we find the derivatives of this f with respect to x, y, z. Therefore dou f by dou x, differentiating with respect to x, each and every term we have to differentiate. Therefore derivative of this term xy with respect to x is y, 0 for this constant term, and derivative of this term, last term, with respect to x is 2z. Okay, and then differentiating f with respect to y, derivative of the first term is with respect to y is x, derivative of this term with respect to y is 2z, and derivative of this constant term is 0. Then dou f by dou z, this time we have to differentiate each term with respect to z. Derivative of the first is 0, derivative of this one is 2y, and derivative of this with respect to z is 2x. Okay, these are the derivatives of that function with respect to x, y, z. Similarly, we find derivatives of phi with respect to x, keeping y and z constant. Therefore, derivative of this with respect to x is yz. Constant term is derivative 0. Derivative of phi with respect to y is xz, and derivative of phi with respect to z is xy. Okay, and then using that Lagrange's method of undetermined multiplier formulas, using Lagrange's method of undetermined multipliers, technique or method, we have the first result is dou f by dou x plus lambda into dou phi by dou x okay, and equating it to 0. It implies if you put these two values, dou f by dou x is y plus 2z plus lambda times dou phi by dou x. Dou phi by dou x is yz and equals to 0. We call this equation number 3. The second, dou f by dou y plus lambda times dou phi by dou y equals to 0. It gives you, if you put these two values here, dou f by dou y is x plus 2z plus lambda times dou f by dou y, it is xz equals to 0, equation number 4. And the last, dou f by dou z plus lambda times dou phi by dou z equals to 0. It gives you, yes, dou f by dou z is 2y plus 2x. We can take 2 common, y plus x plus lambda times dou phi by dou z, it is xy equals to 0. Fifth. Therefore, we have equation number 3, 4 and 5th. Multiply 3 by x, 4 by y and 5 by z, we get. Therefore, here if we multiply by x here, we get xy plus 2xz plus lambda times xyz equals to 0. Therefore, we get that is xy plus 2xz, and if you substitute the value of xyz as a volume, its value is 256. Therefore, plus 256 lambda is equals to 0. Equation number 6. Multiplying this by y, we get xy plus 2yz plus lambda times xyz equals to 0. Once again substituting value of xyz, therefore we get xy plus 2yz plus 256 lambda is equals to 0, equation 7. Then multiplying this by z, we get 2 times yz plus xz plus lambda times xyz equals to 0. Substituting the value of lambda, we get 2 times yz plus xz plus 256 lambda is equals to 0, equation 8. Okay, therefore we have this 3 new equations, equation number 6, 7, 8. Then from equation 6 and 7, therefore if you transfer this, we get minus 256 lambda, and if you transfer this, we get minus 256 lambda. Therefore same term on the right hand side means we can equate left hand side. Therefore equating left hand side, we get xy plus 2xz, that is equals to xy plus 2yz. Okay, xy get cancelled, 2 get cancelled, z get cancelled, therefore we get x is equals to y. From this we get x is equals to y. Okay, and then equating 7th and 8 from equation 7 and 8. Seven and 8. Again, if you transfer, we get minus 256 lambda, and if you transfer, we get minus 256 lambda. Same term on the right hand side means we can equate in this left hand side. Therefore, if you equate that left hand side, we get xy plus 2yz, and that is equals to 2 times yz plus 2xz. Okay, this 2yz get cancelled, x get cancelled, we get y is equals to 2z. Okay, and therefore if we put that values in first equation, therefore that first equation becomes, therefore first equation is the volume x into y into z is equals to 256. Therefore converting in one variable only, therefore I am keeping x as it is. Y is equal to x, therefore we get y as x, and z is equals to, this gives you z is equals to y by 2, and here y is x, therefore it becomes x by 2, and therefore if we put that value here, we get x by 2 is equals to 256. X into x into x, we get x cube as 256 into 2, that is 516. Therefore x cube is equals to 516. Taking cube root, we get x is equals to cube root of 516, and that cube root of 516 is, it is 516 into 2, we get 512. Therefore cube root of 512 is 8. Therefore we get x is equals to 8. y equal to x, therefore we get y equals to 8 and z is equals to x by 2, 8 by 2, that is the value of 4. And therefore the dimension of that rectangular box is length x is equals to 8 feet, y is equals to 8 again in feet, and z is equals to 4 feet. These are the dimensions required or the least material required to construct that rectangular box whose top side is open, and this is obtained by Lagrange's method.